Hi, this is Susan Heath. I'm going to talk to you today about our Eastern Willet migration and nesting study. And this is a joint project between GCBO and the Texas Mid-Coast National Wildlife Refuge Complex. Jennifer Wilson is the biologist at the Texas Mid-Coast NWR, and she was my collaborator on this project. So first we need to talk a little bit about what is a willet. It's a large stocky shorebird. They have long legs and a long, thick, straight bill. In the wintertime, they're gray, and in the breeding season, they get mottled brown and white. They have a striking white patch in their wing, which makes them easily recognizable in flight, and they like to hang out on beaches. So if you've been to the beach, you've probably seen a willet. In Texas, we have willets year round, but we don't have the same willets in the winter that we have in the summer. So I'm going to talk a little bit about that. There's two subspecies of willets, the Eastern Willet and the Western Willet. So the Eastern Willet is Tringa semipalmata, and the Western Willet is Tringa semipalmata inornata. So Eastern Willets are a little bit smaller than Western Willets, and there's some other ways to tell them apart, but the basic thing is you can tell during the breeding season where you are, who's breeding there, because Eastern Willets only breed in the Eastern US and Western Willets only breed in the Western US. So if you look at that complicated map on the left, you can see that in most of the United States actually, but west of that line, there's only Western Willets, and Western Willets breed in freshwater marshes, and they spend the winter on both coasts. So then in the upper right of that graph, we have our breeding Eastern Willets only. And then if you come down a little bit further to the mid-Atlantic and down to Florida, we've got migrant Eastern Willets. And then along the far southern Atlantic coast and around the Gulf Coast, we have breeding Eastern Willets and non-breeding Western Willets. So that's where we get our fact that the willets are not the same here in Texas in the winter and the summer. In the winter, we have Western Willets for the most part, and in the spring and summer, we have Eastern Willets for the most part. The Eastern Willet status is a little bit up in the air. We're not exactly sure what the population size is. The recent estimates were 160,000 Western Willets and 90,000 Eastern Willets. But some other studies have shown that there may be more Eastern Willets than that, but we're not sure. But regardless, the North American Bird Conservation Initiative has them on their watch list as a species most likely to become extinct if they don't get significant conservation action. And that is because they breed, I said before that Western Willets breed in freshwater marshes. Eastern Willets breed in salt marsh. And so with rising sea levels, Eastern Willets are going to have some problems with their nesting habitat, and because salt marshes are going to disappear or gradually disappear, and they may not get replaced as quickly as they're disappearing. So just a little bit about Eastern Willet breeding biology. Their nests are on the ground or in clumps of vegetation. They lay 4 eggs. They incubate for 25, 26 days, and both adults will incubate the eggs, and both adults also care for the chicks after they hatch. The chicks will stay in the nest for a day or two after hatching, and then they're fully fledged and can fly 30 days after they hatch. So the adult females only stay with the young about 2 weeks, and the male stays with them until they fledge. And willets are very territorial. They're very protective of their nest and their chicks. And if another willet gets around, then a battle will ensue. And their food is mostly invertebrates. They eat a lot of insects, a lot of fiddler crabs and things like that. Sometimes they'll catch small fish, but that's not their primary food. So one of my friends from graduate school, Joe Smith, did some research on breeding Eastern Willets in the mid-Atlantic, and he determined that all his Willets in New Jersey, all of his Eastern Willets that were breeding in New Jersey, they all went to this small area on the Atlantic coast of South America in Brazil. So presumably Eastern Willets are encompassing a larger area in South America than just this one little spot, because we have Eastern Willets breeding in more places than just New Jersey. And his research was only in New Jersey. But the point is that they all went to the Atlantic coast of South America. So we don't have any information about where, or we didn't have any information about where our Willets that are breeding in Texas, our Eastern Willets in Texas, where they went for the winter. So Joe asked us if we wanted to take on this study to find that out, and of course we did. So he got one of his advisors to donate some little devices to us called geolocators for us to put on the birds, and I'm going to talk a little bit about that in a minute. So the goals of our project were to determine where our breeding Willets go in the winter. What is the migratory path that they take to get there? What's the timing of their migration? When do they leave Texas? And then when do they come back? And then we also did some vegetation analysis and measurements around the actual nest, since we had to find the nest to catch them. So we didn't want to waste the opportunity to get some information about their specific nest site selection criteria. So we gathered a bunch of vegetation data, and for some of them, we were able to determine their nesting success. And then we also wanted to look at what's their return rate back to the same territory. Do they have fidelity to the same nesting site or not? So we did this study at the Sargent unit of the San Bernard National Wildlife Refuge. That's a 90-acre plot. It's outlined in red there on this picture. The waterway to the south of that is the Intracoastal Waterway, and you can see that the Gulf of Mexico is right down there in the lower right-hand corner of that picture. And that's Jennifer standing out in the middle of this field that we did the study in. And this field has primarily had two different kinds of vegetation: Gulf cordgrass and disticulus. And those are the two types of vegetation that we most often found the Willet nests in. There were some other vegetation types there. There was some sea oxeye daisy and some other things. We did find a couple of nests in the daisy, but the bulk of them were either on a cordgrass clump or in the disticulus. So we had to trap the birds to put the geolocators on, and Willets stick really close to their nest when they're on it. And so we would search for the nest just by searching in the field. We also drug a clothesline through the field to flush them off their nest. And then once we found a nest, we marked it with some small dowel rods so that we could find it again. We put the dowel rods about 5 feet on either side of the nest so that they wouldn't serve as a cue to a predator. We put them far enough away that they weren't right on top of the nest, but close enough so that we knew where the nest was in between the dowels. And then because these birds stick really close to their nest, after we had found a nest, we would come back an hour later or a couple days later with a mist net suspended between two poles and just lay it down on top of the nest. And then when we walked up towards the nest, the bird would flush into the net. So here's a bird. There's the Willet on its nest. You can see the string of the mist net going across. We've already laid it down. That's one of us standing there. I'm not sure which one it is, but you can see we're like 2 feet from the nest. The bird is still on it. So they don't flush from their nest until they're certain that you've discovered that they're there. So this is a video that shows us actually doing this. So I'm holding the mist net strung out on the poles. Jennifer's got the other end of it. We're going to walk through this field as quietly as we possibly can, which is not that easy when you're walking through a wet field with a bunch of vegetation clumps that you can go in and around. Notice that I'm wearing snake chaps. It was an unusual day. We didn't run into a rattlesnake. There was rattlesnakes all over the place, and they actually served as a predator of the eggs of the willet. And so we we had to be careful about that. And my camera person was a friend of mine who was following us. So you can get an idea from the camera that it might look like it's easy to walk through, but it was really not very easy. So we're gonna walk up on the nest. We're gonna lay that net down, and then one of us is gonna get on each side of the net, and we're gonna walk up towards the net, and you'll see the bird flush into it. You can't see the dowels. They're there. I'm sure you get the know what's going on. You hear a willet falling in the background. Okay, so we're at the net. Lay it down very slowly and carefully. You don't want to flush a bird before get it laid down. And then there's the bird flush off the nest right into it. And then we get it out of there, and then we would actually take it out of the field, away, maybe not out of the field, but away from the nest to do what we needed to do. We didn't want to stand right there by the nest. Just,
Awesome. How long do you want this to run?
So after we captured the bird, that would allow us to put a metal fish and wildlife band on there, and also either color bands or a unique leg flag to individually identify the bird. And then we would also put the geolocator on there. So in the first year that we did this, we put color bands on the birds, and that's the bird on the left. And then in the years after that, we put a leg flag, which is what the bird on the right has. So there's that picture down the bottom shows what the geolocators look like. This is a bird, picture of the bird's leg after we put it on there. So this was from the first year. We got the metal band on there, and then on top of that, a green color band. And then on the other leg, we've got a green color band that supports the geolocator, which kind of looks a little bit like a flag. It's sticking out a little bit from the bird's leg, so we had to have that color band underneath it to support it. So this bird was green. And the geolocator is just a data logger that that collects information about the amount of light, records ambient light levels every 15-30 minutes, whatever we have it set at. And they were made by Migrate Technology, which is in England. They are run by a battery, and the battery life is 1 to 2 years. Most of ours only lasted a year. So the geolocator, it records the ambient light levels each day, and from that you can get the time of sunrise and sunset for each day. And then from the time of sunrise and sunset, you can get the time of relative noon and midnight. And then from that, you can calculate the geographic coordinates roughly. These things are only accurate to maybe 50 miles or so. So you're not getting an exact location of the bird, but it's plenty good enough data to tell a migratory route and where a bird spent the winter. So we also took measurements of the birds, and that helped us in separating the sexes, because females are larger than males. And we recorded the weight. And then the first year we collected feathers and blood from each bird for a systematic study on willets that was being done in the entire range of the Eastern Willet. So here's a nest in Testiculus. The left picture is, there's a nest in there, but you can't see it because it's so well camouflaged. The right picture is one of us holding the vegetation back, so you can actually see that there is a nest in there. And then this is a Gulf cordgrass nest. Again, you can't see the nest in the picture where you're standing back, but it's on top of one of those clumps. And in the right picture actually shows the nest there. So I said we also did vegetation sampling, and this is some of that we did. We took measurements of the actual nest site, the height, width, length of the nest, the height of the substrate that the nest was on, and what the species was that the nest was in, and the maximum shading height, meaning the maximum height of the vegetation that would provide shade for the nest. And then we also did some vegetation structure measuring and vegetation density. We had it's called the Dobbenmeyer frame, which is just a frame made out of PVC with 4 1-meter compartments in it. We would lay that down with the center of the frame on top of the nest. We did this after the nest was complete, so we weren't disturbing the birds. And then we would characterize the vegetation in each 1-meter transect. So here's our results. There's our friendly rattlesnake up there on the right. Couldn't leave his picture out since we saw so many of them. So we found 40 nests. We banded 30 birds and we put out 24 geolocators. And of those 24, we got 10 geolocators back. And the reason we didn't get them all back is because some of the birds didn't come back. Some of them came back but had lost their geolocator. And some of them, like the one down in the left corner, we just could not catch again. That bird would sit up on top of this telephone pole and taunt us, calling constantly. We never could find its nest again so that we could trap it. And so I made that little cartoon for Jennifer one day because we were so frustrated with that bird. So the other picture there shows where all of our nests were, and you can see there's some nests in 2018, 2019 that were down in another little section that was out of the refuge. That's because some of the birds moved over there, and because they had geolocators on them, we had to move over there to try to get the geolocators back. So our nest success, you can see that it's pretty low. There's only 1 year where it was above 50%. And these birds, they suffer from flooding. There's a lot of predators out there, the rattlesnakes. There's also caracaras, coyotes, raccoons, possums, all that kind of stuff. If they found the nest, they would eat the eggs. So the overall nest success is pretty low for the species. And there's a complicated slide that shows the nest site measurements that we took. But as I said, most of the nests were in Gulf cordgrass and in Disticulus. And then here's another complicated slide about the vegetation patches. There's our picture of our Dobbenmeyer frame up in the top, and how we would characterize the vegetation. So the graph on the bottom is comparing the height of the average height of the nests to the height of the vegetation that the nest was in. So you can see that the nest heights varied a lot from year to year. And in 2016, the nest height was pretty high. That was a really wet year. And a lot of the birds just didn't even nest. We found very few nests that year, and the ones we did find were positioned a lot higher than in the other years. You can also see that the vegetation was a lot taller than actually where the nest was. And that was for concealment and also to provide shading for the bird that's sitting on the nest, because it's pretty hot just sitting out there in the middle of the field in June. And then the other graph is showing the comparison of the nest heights and vegetation to a random point in the field. So we took these measurements at the actual nest, and then we generated random points, and we took the same measurements at random points out in the field so we could see if the willets were selecting specific things. And you can tell that in most years where the nests were, the height of the vegetation was taller than the random points. So I said we got 10 geolocators back. One of them failed and didn't have any data, so we got data from 9 of them. And that little picture just shows what the geolocators look like before we put them on the bird. So what do we find out? Well, one of them went to Nicaragua. It was a male, and he left on July 9th, and he arrived in Nicaragua straight through flight across the Gulf of Mexico in 2 days. Just pretty amazing. This one, the battery died before the bird migrated back in the spring, so we only got data for one direction. One of them went to Costa Rica, and this one we got data both ways. So it took 3 days to get to Costa Rica, again in July, and then it took 2 days to get back to Texas in March. Two of them went to Panama, and this is the first one. Took 2 days to get down there and 3 days to get back. Again, these were all straight through flights across the Gulf of Mexico. And then this is the other one that went to Panama, and we only got data one way on this one. It took 3 days to get down there. And 3 of them went to Ecuador. And the very first one that we got back went to Ecuador, and we were very excited to find that out, because if you remember, all of the Atlantic coast Eastern Willets went to the Atlantic coast of South America, and all our birds were all going. I mean, we were excited to find out that our bird went to Ecuador, so that's the Pacific coast, so completely different. And then as we got more and more geolocators back, we realized they all went to the Pacific coast. So we got data on this guy both ways, and 3 days to get there, 3 days to get back, again in July and returning in March. And here's the second one that went to Ecuador, 3 days and 3 days, again, also July and March. And the third one, same thing, 3 days. We only got data one way on this guy, and he went in July as well. And then there was one bird that was right on the Ecuador-Peru border, so we're not sure, you know, could have been going back and forth. Birds don't care about political borders. And it took 2 days. It only took 2 days to make that straight through flight all the way down to get to Ecuador or Peru. And then the last one went to Peru, and this one took 6 days, and it made a stopover on the Yucatan Peninsula for a day. And so it had a little stopover. You know, there's no way to know why, since all of the other ones went directly, but obviously it might have been flying against a headwind and it got too tired. It had to rest for a day. No way to know, but it did make it down there, and it made it back so that we could get the geolocator back. So our willets that we got our data on all went to the Pacific coast of South America, and that was unknown data prior to this study, because previously all willets that were on the Pacific coast of South and Central America were assumed to be Western willets. So we showed that that's not always the case. There are Eastern willets spending the winter there, and the fall travel window was always in July, and the mean travel time was 3.125 days. The spring travel window was always in March, and the mean travel time 2.75 days. It makes sense that the spring travel window would be shorter, because most migratory birds are in a hurry to get back in the spring to claim their territory, and so they make that flight quicker. That's been shown with a lot of other species as well. So we found out some really cool information about our willets. We're still analyzing the vegetation data. We published a paper on the migratory routes and where they spent the winter. That's going to be published in Water Birds this month, and then we're going to submit the paper for the vegetation data once we get done analyzing it. So I always have to thank our funders. We got a small amount of funding at the beginning from the Texas Midcoast National Wildlife Refuge Complex, and then we got a bigger grant after we did our proof of concept. We got a bigger grant from the U.S. Fish and Wildlife Service Coastal Program. And we want to thank the people who helped us along the way. Larry Niles actually donated the initial set of geolocators that we used. And then once we got our own funding, we were able to buy more. And we got the geolocators from Migrate Technology, and James Fox there was a big help to us. If we got a geolocator back and the battery was dead, we were not able to get the data off of it. We had to send it back to him so that he could get it off. And then Joe Smith, my grad student friend, got us started on this. That's a picture of him there on the right. And we never would have did this without him. So definitely want to thank him. And that is the end of the presentation.